Okay, everybody. So we thought we'd have a bit of a chat today about Git and how we use software versioning, Git and GitHub, and these kinds of things because they're kind of critical and crucial to software engineering today. So I have a couple of people here with me to have a bit of a chat, and we're going to do a sort of a bit of a rehash and a recap, and have a chat about how we do Git. So I suppose a little bit of background first. Back in the bad old days, we just used to have bits of software on our computer and we used to make changes and we'd break things and we wouldn't know why. And it was all pretty horrendous. And you'd end up having different folders with numbers in and different zip archives and all sorts of stuff. And life became a little bit more sensible, and we had version control strategies to be able to keep track of different versions of different bits of software source code that we were using. And one of the older ones that I remember is CVS, which I'm sure some people will remember. Over on the Microsofty side of the world, there was VSS, Visual Source Safe, which I have done battle with on many an occasion. And then we had something called Subversion, which is probably still just hanging on somewhere. And then this Linus Torvalds chap got a bee in his bonnet, decided to do something better, and invented Git. I think it's probably apocryphal, but some people seem to think that it might be called Git because he's a Git. Now, I wouldn't say that. I don't think that, but it would be nice to know if that was true. And then we have Visual Source Safe evolved into whatever Microsoft is doing today with Team something or other, I think. And there are some other ones, more recent ones, which I can't think of and can't really remember, don't really care about. So there's two main strategies for doing this kind of stuff. The problem we've essentially got is that as an individual developer, you really do want to keep tabs on the changes that you make so that you can revert back to things that worked when you break things. And you can go back to old releases when you've released some software into the field and you get a problem, and then you want to try to replicate that problem. Well, you need to be able to go back to the build of software that you are running in the field to be able to test that. So often you will keep the binaries stored somewhere as well, so you've got something absolutely replicable. But it's also good to be able to go back to the right version of source code to do your debugging, because things may have changed in the interim. But as well as that individual developer, more and more now, and in most cases probably, we're talking about teams of developers. So we've got different people on the team, maybe in different places, who are all beavering away on different parts of perhaps the same software product, and they'll be doing their stuff. So how do we manage to keep track of what everybody's doing? And one of the, for me, rightly or wrongly, this is my recollection, but back in the old days of Visual Source Safe or VSS, what used to happen was you'd have a set of source files which would be checked into a server, and they would exist on the server. And then you would sort of check out those files to use to sort of build your local copy of what you were doing, and you would lock individual files. So if you needed to work on a particular source file, you would lock that file and you would be making your changes. And that meant that nobody else could make any changes to that file. And you can sort of see why that might be sensible, but you can also see why that wouldn't scale, because unless you manage things so that different people are working on different parts of the source code, source base, you end up with people who, person A is trying to change something and person B can't change it because it's locked. And it really doesn't work terribly well when you have a few people who are trying to do similar kinds of things. So another strategy came along in parallel, which was more to do with what we call diffing and merging. And this idea is that everybody can work on everything at the same time, which is a very sounds a very open sourcey way of doing things. It could be slightly chaotic. And what you do is you use tools to work out what a person has changed and how that can be merged back into the main set of source code that you've got. So I might make a change to a file over here, and somebody else might make a different change in a different bit of the file over there. And then I'll try and merge my changes back in, and they'll try and merge their changes back in. And if it's all fairly straightforward, that will happen automatically. And if maybe we've both tried to change the same lines of something, the automated systems don't know how to resolve that. So they will say, there's a conflict here. Somebody needs to sort of step in and figure out what we need to do. I think VSS did adopt that other model of doing things eventually, and that kind of model is very much the model that something like Git works on. Now the next thing is that back in the bad old days again, this was very much what we would call a client-server system. So you would have your sort of local copies of your files, but they would be checked into a single centralized server where everything sat. And that might be a computer on your local intranet in your business, or it might be a computer somewhere out on what we used to call the World Wide Web, I suppose, before it became the cloud. And you didn't actually have lots of local information on all these versions and things on your local computer. You just had that on the server, and your software would talk to the server to do things and work out what was what. And I think that's probably, I couldn't possibly speak for him, one of the things that Linus Torvalds found irritating. And so this idea of Git is quite different. And with Git, a key point about how it works is that you have a Git repository, it's called, which is where all the particular bits of software and files for a particular project might sit. And that Git repository contains all the information to do with all the history of all of that stuff. And that Git repository can sit on a computer somewhere in the cloud, and often does. And indeed, we'll come on to talk about GitHub as one example of one of the kinds of places it can sit. But it also sits on your local computer. And that's absolutely critical to understand. So again, in the bad old days, if I was using a source control system, which was client server based, and the server went down, we lost the server, big problems. I might have some kind of local copy of files on my local computer, and others might too, but I wouldn't have the entire history and metadata pertaining to everything that had gone on. So you've got a single point of failure, basically, and that's generally never a good thing. Now with Git, it's different. So with Git, the entire database almost, if you like, of all the history of what has been going on is transferred locally. And many different people have many different copies of this database, which of course can lead to confusion, but you've got lots of copies of these things all over the place. It's quite a good thing. You don't have that single point of failure. Obviously, I'm oversimplifying. It's not quite that simple. You may not, particularly repositories with all the history for some projects, if you look at the Linux kernel, can get very big. And you might not have all the information on everything all of the time. It's certainly possible to do that, but it's kind of slimmed down a little bit, mainly because it would take so long to transfer all that information. But that's the kind of, that's the nuts and bolts. That's a basic idea of how this stuff is supposed to work. So you have different Git repositories, which may be different versions or forks of the same historical set of software. And I might have a fork of what somebody else is doing, and I might have that somewhere in the cloud on GitHub. And then I might have my own repository on my computer. The people I work with have their own repositories on their computer, and we can push things up and we can pull things down and we can move things around. And it's really very flexible. And I think because of that, it can be, took me a fair old while. I'm no expert on this stuff, but it took me a fair old while to even get to grips with the basics of some of this, because conceptually, you've got to kind of have a bit of an idea of what all that means, what I've just been talking about, committing and pushing and these kinds of things, to be able to sort of get to grips with how to run some of the commands for Git. So that's what we do. Now, hopefully, the folks that are with me today are going to jump in with any questions as we talk here and correct me on the things that I get wrong, which I undoubtedly will do. Shreya's here with me and has been going through some of the beginning bits of this and explaining them. So you will, I'm sure, have some ideas on whether I'm getting this right or wrong. I've got a pre-installed setup here, so it's going to be slightly difficult. I don't want to start everything from scratch because we don't have time here. But basically, I'm on an Ubuntu machine, and I can see that it's a Linux 6.8 kernel on Ubuntu. And I've got Git installed. If I needed to install Git on Ubuntu, then I would do something like sudo apt install Git. Often it's quite useful to do something like sudo apt install build. Can't really type and talk at the same time. That's going to be a problem. I can't remember if it's build essential or build essentials. I think it's build essential, and that gives you a bunch of basic stuff for doing software development, like GCC compilers. That may actually not install Git, so you'd probably do both of those, that and Git. That gives you the Git command, and we've got all sorts of things that we can do with Git. It's can be quite overwhelming, really, to do this stuff. What I'm probably going to try and do, and we'll see if this works, add a user, Git user. Bet it will. Let me see. It's a bad password. Okay, let's try. Okay. So I've just created a new user. Hopefully that will be useful and that will become self-evident why I've done that in the future. Yes, you definitely can't type and talk at the same time. Yes. Oh, come on, come on. Fine. Right. So I'm now the Git user. Just have an ID, tells me that you're the Git user. And if I look at the current working directory, I'm in home Git user. That's where I live. And if I have a look at all the files in that directory, there's a lot of dot prefixed files, which are hidden files normally. So if you just do a list, you can't see them. If you list all, you can see them. And that's the sort of basic setup when you create a new user and that type of thing. And we care about that because we're going to set up some credentials to use Git, and that will end up in a .git folder in here in the users directory. But for now, let's not worry about it. So, sorry. Okay. Okay. So we're just having one of the folks here has dropped off and is going to rejoin us. In the meantime, what I'm going to do is to go over to GitHub. There are other, we have to make this statement, don't we? There are other commercial Git repository offerings available to you. I'm not making any statement on that. I use GitHub because I've done for a long time. I like it. There's all sorts of other things you can have a look at. Gosh, I mean, Atlassian I've got there's Bitbucket, I think, and there's GitLab, and there's all manner of different places that you can go and have a look for this. So you do that. Now, this is my organizational page on GitHub, which is the business, which is Dynamic Devices. And, we do a lot of stuff here and we try to keep what we're doing open as much as possible as well. So there's a myriad of different repositories, because again, that's what we call them, isn't it? And you can put any grouping of files in a repository, but it will typically be some kind of project basis. Excuse me. And so what I'm going to do is I'm going to create a new repository, which I do with this new button here. I'm going to give it a name. I don't know, so we'll call it Git test. Simple repo to test out using Git. We're going to make that public so anybody can see this stuff. You've come back to join us. Is that working? There you go. So what we'll do is we'll make that public. We will add a README to it because why not? Remind me to talk about git ignores. I'll do that. Should we add a git ignore? Let's add a C language git ignore. I'll explain what that is shortly. And let's give it a license. And we're open to all here, so we'll give it an MIT license. I don't think we need to talk about those this time. Licensing is a whole chat in itself, isn't it? So let's create that repository. Boom. Ta-da. Wow. We've now got a Git test repository within the Dynamic Devices organization. If you look at the URL for that, github.com, organization, name of the repository, and that's the formatting that this takes. Don't really want to emphasize the whole use of GitHub too much, as it should be quite intuitive, and I think you can figure all that stuff out. It tells you lots of useful, interesting stuff. Tells me the branch that I'm on. Nowadays, we don't like the idea of using, well, we shouldn't be using the idea of master slave in our conversations. So old repositories will talk about master for legacy reasons. New repositories use main, which is much more acceptable. And you can create different branches and forks and tag things, which we may come onto. But that's our main branch. Those are our initial files. We created a README. We put an MIT license in there. We've got a git ignore. And it says who did what. So we've got one commit, which was my initial commit from somebody called AJ Lennon, who's me. And it tells us what my commit was. And it tells us that there were 3 files committed and what those files are, what's in those files. If I go back to code, I can go and I can look at the license file, and where it can display a file textually, it will. And there you go. It's showing me that's a canonical MIT license. Here is a hash, which is a unique number for a commit, which should be a globally unique number. And I can do all sorts of things I guess I won't go into. There's a range of different tabs up at the top for raising issues and problems, for people contributing their changes in what's called a pull request. You can use continuous integration with GitHub Actions to build your software in the cloud, which is a very cool thing, which we talk about elsewhere maybe. And then you can have projects, wiki documentation, there's other bits and pieces. So all very interesting. Now, go back to code. What then we sort of care about is how do we get this stuff down onto our own computer? And we do something called cloning to do that. So we do a git clone. So as I said, I'm now Git user, and I'm gonna create a folder called projects to follow Shreya's example. And in projects, I'm going to git clone, and then I need to give it a URL to go and get this repository from. And if I click on code up here, there's a couple of different ways that I can get this URL, and that's changed over the years. I may be a little bit wrong here, but essentially, nowadays, I think it's true to say, well, firstly, you could download the zip. So if you don't want to get involved in all this stuff, you just download the zip file and do stuff with it. That's sort of the most straightforward way. But if you actually want to do a Git, you can use the secure HTTP URL, which is available without authentication and useful for public repositories. And that would be where you want to pull down some information from a public repository, so you don't need to authenticate, but you're not going to be able to send any information back, because anybody with any sense, and I think Git lets you do this, but anybody with any sense isn't going to let you push random stuff into their repository, because, you know, bad things could happen. So you will tend to have to authenticate to be able to push information into a repository, which HTTPS won't let you do. But just for simplicity, we're going to copy that link and we're going to git clone from that link. And that's told us that it's doing complicated Git things, one of which is to compress the stuff it's transferring, which it does to reduce the bandwidth usage between A and B. And it's pulled all this stuff down. And if I have a look here now, I've created a Git test folder. And in that folder, I've got a license and a README file. How exciting. And if I look at what I originally created, I've got a license and a README, but I can't see the git ignore. Is that missing? Well, I told you it's a prefixed file, isn't it? So if I do an LSLA, I do actually have that git ignore file. Yeah. I also have an extra folder, which is the .git folder. And that's really quite important. We ignore that for the purposes of doing our programming or whatever, But that's where all the magic happens. That's like the Git database, if you like. That's where all the metadata on all the history and all the settings and all the bits and bobs is stored and goes. So if you fiddle about with that, you're likely to have a lot of problems, I would say. So unless you're super advanced or more advanced than my intermediate Git usage, I would stay very well away from changing that file. So we got this. Now I can then maybe one thing I want to talk about quickly is the README file. You can have different kind, README is a README, isn't it? But in Git parlance, you can have a normal README file, or you can have a readme.md file. And a readme.md file is pretty cool because it lets you write documentation or information in a Markdown format. So that's Git Markdown. And if we do a quick Google, let's find the Git Markdown cheat sheet, which I go back to periodically. And there's a cheat sheet here of all of the ways that you format your text within Markdown. And this, there's many different ways of doing this, as many people will know, but there's some just easy textual ways to create headers and to create code blocks and similar kinds of things. I'll show you just a couple. If I say, a second level header, and then I'll say this is text, and then I'm gonna say here echo hi hello. Yeah, let's do the most basic thing we can do. Hello Git world. There we go. And I can also do a code block is a code block. And I can close that down. I could also do tables and all sorts of stuff, but I think that would take too long. So what I'm going to do is save that file, and I've got a README file here. See that README file there? Obviously, we go back to our portal and reload that. Nothing has changed because I'm doing everything locally here, yeah? So that actually has, what that's done is it's changed my local file, but it hasn't told Git, the Git repository, the local Git repository, anything about that. Just my local change. So I'm going to say to Git, tell me what I've changed here as opposed to what you think you know about. So I'm going to do Git status. And then it says, aha, you have modified the local README file, which I have. So that makes sense. And I'm, and it's quite, it can be quite helpful. It says, okay, so no changes been added to the commit. Use git add or git commit to do this stuff. And it's basically saying, you haven't told me about this. If you want to tell me about it, that's how you do it. So it's trying to help me out. Now, I might say, all right, well, you've told me about the file that I've changed, but I kind of want to know what's changed. So how do I do that? Well, I can do git diff. So if I do a git diff, it tells me what I've changed. Now, I've added in those bits to the file. So that's what it tells me. That's great. You can see up at the top in sort of off-white, git test simple repo. That was what was there before. And you can see in what's called a diff format, you can go and look up, where it's prefixed with a plus, it's telling me I've added all that stuff in. And I've done some bad things because we really shouldn't end lines with spaces, and we really shouldn't have extraneous spaces. And that red stuff there is basically saying, that's a bit naughty. So let's not be naughty. Let's just get rid of that, see where those spaces are, and let's get rid of those extra spaces. And now if I do a git diff, I've got one new line at the bottom. Might be difficult to get rid of that. There we go. Ta-da. So that looks a lot better, doesn't it? Don't like to see red. So then what I'm going to do is I'm going to commit my changes into my local repository. And that isn't going to go anywhere else, as we said. That's just going to be here. That's just going to be local. So before we do that, let me have a look at the log of what Git thinks has been going on, because that's quite helpful. So I'll do git log. And if I do git log, it says, okay, you've got a commit here, which has got a really big number, which is that unique ID. Should really be a globally unique ID. And it's saying that you're doing that on the head, which is on the main branch. We talked about that. We don't need to worry about the other bits. And so who did it? Well, that's me. And when did they do it? And what was the message to do with it? All of those things. So now what I'm going to do is going to do a git add the README file, which adds my file to be staged for a commit. It's not actually committed it into the repository yet. It's staged it. It's added it for staging, which was what that message meant before. And if I now look at git status, it's saying to me that, we're on branch main. Okay, that's cool. And we have some changes to can be committed because I've staged them. And I've got a modified file in green, readme.md, which means that those modifications, those changes that we looked at, if I do a commit, that's what will be committed. So let's do it. Let's do a git commit. I always do a git commit -s because I think that's good practice. Others may disagree. Often when we are committing code into a repository, particularly if we're going to try to create pull requests or create requests for other people to include our changes, which hopefully we want to do because we're helpful people. This is open source world way of doing things. It's good to know who did what. So that sort of already will be in the Git log. You've seen Alex Lennon. But we actually want to sort of sign that off ourselves. The S means sign, and that will add in a little signature on the bottom so that you know it was me that was doing it. Now this, I think, won't work. So let's have a go. And indeed, ta-da, it didn't work. I think computer's grand. Now, you remember I said to you that I was going to create a new user. And one of the reasons for this was to go through things from first principles. And that's because this new user has never set up any sort of settings for doing git commits and things. And two most basic things you have to do globally when you're using Git as a user is you've got to tell it your name and you've got to tell it your email address. And that's because these are quite important things, particularly when we're working in teams of individuals. We want to know who did what, when they did it, and why they did it, and we can backtrack through things, maybe even talk to them and ask them what was going on when they did this. So what we'll do, and it again has been very helpful, it tells us what we need to do. We'll do a git config global user.email, and we'll give them a git user at dynamic devices. And then we'll do a git config global user.name git user. And they're now set up. So now I should be able to do a commit. So let's do that commit. Git commit -s because I like to do that. Oh my word, isn't that amazing? So you can see anything prefixed with a hash, as you probably get, is a comment. And it's sort of telling us things about stuff. It's telling us the change that's going to be committed, which is good to check. It's what we expect it to be. That -s added signature in saying that, yep, that's me, git user, I signed it off. And I'm going to say modified the readme.md to show use of Markdown. Now, there's a whole big debate around what a good git commit message looks like. I don't think I'm going to get into that much. I suggest you go and look at that yourself. You will know that, if I have a function that does a job like, turning the screen red, and I call the function turn the screen red, and then I write a message about the function saying turn the screen red, this is not ever so helpful. I've got three things all basically doing the same thing. So I would say, others may disagree, that essentially what you're trying to do is on the first line, give a useful indication of what you've just done. So you may have committed one file or a few files or some changes, I don't know, but other people are going to come along and look at the Git log. And in its condensed form, they're going to see that top line message. And what we'd like to do is to help people who come along to be able to look at a one-line thing and have a pretty good idea what was going on. That's helping. So I would keep that in mind. Then you may need to say some more detailed things about why you did what you did and what you're referencing and who knows what. It very much depends on the complexity of what you've been trying to commit in. Sometimes you won't bother. Sometimes you have quite a lot. And that all comes down to what you're up to. But the key thing to remember is you've got a one-line message, which is what people will see. Then they can drill down to see all the rest of what you're talking about. So break it up that way in your head in terms of what you're trying to do. We won't really go into it too much, but with some systems, they sort of extend this, and we might be fixing an issue. And you might sort of put in 123, which an extended version of Git might know is issue 123, and it will link what you're doing to issue 123. And that probably happens with GitHub, and Atlassian does things, Jira does things, different ways of doing them. But that's a little bit of an example, yeah. But if I do issue 1, let's see if I can actually do that. Issues, going to create an issue, a test issue, and again, one-line thing, put some more description in, going to submit that issue, going to assign myself to try and fix that issue because why not? So it's on my shoulders now. I don't think this is really going to work, but we'll see. So #1, often it'll be that kind of thing, maybe issue 1, something like that. So I'm going to save this file and exit out of my editor. I use Nano. There's different editors. Other people use Vine, other people use integrated development environments, and all this stuff plugs into Visual Studio and all sorts of things. Lots of different front ends for Git. This is the basic command line stuff. So I've done all that, and it says it's modified the README and one file changed, etc., etc. Well, great. Now, if we look at Git log, it's telling me that there are 2 entries. There was my initial commit, and then there's what I've just done. So modified that, some more settings, signed off by, super duper, great. I can also diff going back through this log. And most things where you're comparing something against something else will use these unique commit hashes, they're called, these unique IDs. So if I want to see the difference between what we've currently got, which is on the main, head of main, and this previous commit, which is this one here, I can say git diff against that commit hash, and it shows me the difference. Ain't that grand? And I can go back as far as I want doing that kind of stuff. There is a short form of these hashes, which I think just uses the first sort of 8 of them or something else, but you can figure all that stuff out yourself. So now I've got my local repository. I've staged my change. I've committed my change into the repository. We don't worry about this, but it's all done magic things inside the Git folder. Stuff has happened. I never go anywhere near that. Advanced use only. And that's changed all that stuff, but it hasn't changed anything in the remote repository because everything is local here, right? So I can be doing all this stuff, and you could be doing this, and lots of other people could be doing this, all with the same repository, operating on their local copy. Now, at some point, of course, it's very bad practice just to keep all this stuff local in case our computers blow up or get stolen or who knows what happens. So we generally want this stuff backed up. And certainly if we're working in a team, we want to be able to share what we're doing with other people. That all gets a bit more complicated, but in a very simplified form, what we do is we push our local copy of the repository up to some endpoint. And that's a remote endpoint. So funnily enough, we can have a look at what that is by using Git remote. In Git remote, the standard term that is used, or that doesn't have to be used, is origin. And so when we cloned, you'll remember from that URL, it set up an origin, which is where we cloned it from. And if I do git remote -v, V for verbose, as you know, then it shows me the origin, and it shows me that URL. Isn't that great? And the URL for a fetch is when you're pulling things down, and the URL for a push is when you're pushing things up. They will usually do the same thing. Now, so I want to push the changes I've committed to my local Git repo up to the remote endpoint, which is origin, which is that repo that I set up on GitHub. So let's try doing it. It won't work. Git push. Now it wants me to authenticate. And this is where I get a little bit confused because you probably still can do this, I don't know, but Git stopped. They kind of locked down a lot of this stuff. Basically, because it's not good practice to be certainly not doing this all the time. And it's a pain in the rear end as well to be doing it all the time. You can probably automate that stuff, but really what we should be doing is using public key crypto to do our authentication, because it's the right way to do stuff. It's a secure way of doing stuff, and it gets automated. So what we're going to do is we're going to try and set that up. Now, at this point, I'm going to have to go and ask Shreya how to do it because I can't remember how to do it. What I will say is I think GitHub is quite helpful with this. So I'm going to go over to some settings. And in my settings, you're going to see, if I can remember where it is, no, not the repository settings. I need my user settings because it's the user authenticating to do the commit. So if I go into user settings with your list, other systems, again, will do things in a sort of similar kind of way. You want to look at SSH GPG keys with GitHub. Brilliant, thank you. And if we look at SSH and GPG keys, we will see, helpfully, check out our guide to connecting to GitHub using SSH keys. How fantastic. And in there, it talks about how to do all of that kind of thing. Now, we don't want problems. Am I on the same page as you, or generating a new SSH key? That's what we want, isn't it? You can see all this stuff, go back and find the bits and bobs. But this is basically in and around where I go to look. Basically, don't really want to get into public key crypto at the minute. You haven't really got time for all that. And we're sort of running to the end of this session. Clearly, we're going to have more than one session on this stuff. But basically, what you do is you create some secrets, which you're going to use for authentication. And when you do an SSH key, it creates a private key and a public key, two different files, usually, say. I'm sort of simplifying it. And what you do is you keep the private stuff super private, because that's like your secret stuff. And you give the public thing away to anybody you want, because it's public, private, public. That's where it all sort of comes from. And what happens is, in a very short-circuited kind of way, if you give the public key file to somebody, then you can use your private key file locally to prove it's you to them. And other people can't do that without that private file. Lots more to it. Go and look at Brushna if you want to know about how crypto works. But for us, as mere software developers, it's magic. So what we're going to do is we're going to use a key generation command, which helpfully this gives us SSH keygen, and it uses ED24519, which is a particular kind of crypto algorithm. Over time, the algorithms that we use change, as sometimes algorithms are found to be insecure. We've got RSA, DSA, we've got elliptic curve cryptography, different key lengths, all manner of things. Again, don't worry about it. It's magic. So, or if you do need to worry about it, go and ask your IS person. So what we're going to do is we're going to do an SSH keygen using this ED crypto algorithm. And what did I call myself? I think I'm Git user at Dynamic Devices. Go to UK, and I'm going to set a default file. Remember I was telling you earlier on that we were going to have this .ssh directory? It doesn't have to be in there, but that's where it goes by default. That's where it looks for it by default. So that's where we'll put it. The key is the private file, which is going to be called by default ID, blah, blah, blah. So let's do that. Let's not change it. And do we want to enter a passphrase? Right. So again, getting into the magic of keys and things now. This is sort of like a second level. It's like a two-factor authentication type of thing. If I create this public-private key pair, anybody with access to my laptop can just use them. Or anybody with access to the file actually somewhere else can just use them. Do I care about that? Maybe I do, maybe I don't. If I do care about that, a second level of security is that I can also add a password or passphrase onto my key, so that even if you had access to my laptop or access to my private file, you still can't do anything with it unless you also know my password. See? Now, we could have a discussion about whether that's an important thing to do. Kind of is. For me, these keys at the level of authentication I care about with GitHub, I'm happy not to put a passphrase in there. You will make your own decision. So I don't put a passphrase in there, and then it gives me a representation of the key that we've created. And you can see that it's created the ID file, which is the private key, and the id.pub file, which funnily enough is a public key. If I look in my home directory in the Git folder, if I've got this right, that's slightly, sorry, what am I doing? Can't type and talk at the same time. But look at my home directory in the SSH folder, I see those two new files. And if I just show you what they look at, because it's quite interesting to look at it once in a while, and I look at the private key file, that is the begin open SSH private key. And if I look at the public key file, that is the public key. Again, we can give the public key to anyone we want. We do not give the private key to anyone we want. And depending on where you are, you can revoke keys, and you can, all manner of things. There's keychain, there's a big long conversation we could have, but for now, it's just magic. So we've got some keys. Now, we've said that the URL I was trying to use for my remote was the HTTPS URL. And you can't use SSH keys with an HTTPS URL. Funnily enough, what you need for your HTTPS URL is, for your SSH key is the URL for SSH. And that's what we saw here earlier on. And it defaults to that because that's kind of what it wants you to use. So let's grab the SSH URL. Now, what I could do is to add another remote, or I could change the URL for the current remote. Either's best, really. Depending on what I'm doing, I use either mechanism. Let's add it in for now. So if I add an SSH remote with the SSH URL, git remote add, and then I look at the remotes, you see I've got the SSH stuff now as well. So that remote is called SSH. It's actually going to the same place as the other one, but it's a different protocol. That's what we care about, isn't it? So if I now if I do my git log, those are the changes I've made. And now I want to push these changes somewhere. Where am I going to push them? Well, I'm going to push them to the SSH remote. And what am I going to push? Well, I'm going to push the current branch I'm on, which is something we haven't really talked about. What is that? Well, if I type git branch, I did talk about using main before, didn't I, as the default branch? Yeah, master is the old way of doing it. Main is the current correct way of doing it. So if I do git push to SSH remote, which we just set up, on the main branch, which is the default one that we're using, and it doesn't work. Well, firstly, it says, do you trust this server? And we won't worry too much about that. That's part of the protocol to ensure that people can't be pretending to be our server without actually being our server. And you can verify the key of the server to make sure that it is the case. I mean, at the level of what we're doing here today, I'm not too worried about it. And once you've verified it once, that's done. And it will only warn you if something changes. You don't need to do it every time. You only need to do it the first time. So we've done it, and it didn't work. Why didn't it work? Well, as I said to you, we changed the URL, so we're using the right protocol for SSH, and we've created a key for ourselves, and kind of the local SSH stuff knows about that key, but the server doesn't know about that key. We haven't told, in our case, GitHub about that key. So it's saying, permission denied. I don't know anything about your key that you're trying to use here. You're not fiddling about with this stuff. Yeah. So what we need to do is we need to tell GitHub that it's okay for somebody with my keys that we've just created to do stuff. And there's a set of GitHub settings to do with organizations and repositories and who can read stuff and write stuff and change stuff and this and that. And that's, something that you can read up on. But for our purposes, we just need to get that authentication, those credentials in there. So what we're going to do is we're going to go back and we're going to look at where we put our public key. There, remember, not the private key. And we take the public key, so let's copy that. Each different sort of front end to a Git server will do things in a slightly different way. But with GitHub, what we're going to do is go back to my personal settings, and we're going to go back into my keys, and we're going to add in a new SSH key, and we're going to call it test Git user key. It's an authentication key, and it very helpfully tells you what it should look like. And then we put our key in there. The format of that, as you can see, is it tells you what kind of algorithm it is, has a key itself, and it has a helpful email URL that you set it before, so you get a big idea what's going on. But the important thing is that key there. So we're going to add that in. Oh, my word. Now, that's interesting. So I'd forgotten about that. So I've got two-factor authentication set up. So when we're doing stuff that could be problematical, like giving random people access to the organization and the repositories, we're going to use a GitHub module, which means I'm going to have to find my phone, which is not something I'm expected to have to do. So, I'm a tune while you wait. Here we go. So that's now going to pop up on the phone for two-factor authentication. Worth having somewhere in this workflow. You're going to make your decisions about how far you go with all of this, of course. So I'm going to approve that now. Ta-da, it's approved. So we've got a test user GitHub key. I can actually, I'd like to show you that. That's been added in there. Key's been added when it was added, when it was used. I can delete it if I want to stop access from our test Git user, which believe me, I will be doing shortly after I've chatted to you. And then we go back to the code. Go back here. There you go. Now, again, I just want to emphasize to you that that's the README file that's up in the cloud, and that's the rendering of that file. And I'll prove that. I'll sort of reload that page. Now, we've set the URL correctly. We've set the user up. We've set the keys up. We put the public key on the remote server, and we should be able to now push. Now, if I do the push of SSH and main, wow, that's different. Something happened. So it said, done a bunch of things, compressed things, transferred things, sent it. So what should have happened is if we refresh this page, it should change. Oh my word. You'd almost think I knew what I was doing. And in here, you can see we added in, if we go way back to that Git Markdown, where there was a hash, I put in 2 hashes for the second level header, that becomes bolded. And where I put in those backticks, either at the beginning and end of the line or 3 backticks and then bottom 3 backticks, you see it renders that into a much more easily readable way of doing things. So that's a pretty cool way of doing stuff. If you click this edit button here, you can see actually the original stuff that I entered. You can edit it in the portal, in fact, which can be quite useful. And there's the preview of what we were doing. So you can see that I did my change, I staged it, I committed it, I pushed those changes on the main branch up to the server. That changed what I'm looking at in the GitHub portal. We now have 2 commits. If I look at the history of those commits, I can see that I've now modified the README MD to show the use of Markdown. It seems to have been a bit clever, and it may even know about the issue that I referenced. And oh my word, if I click on that, it links through to that issue. And I think I've now resolved that. So I'm going to close the issue. Job done. How fantastic is that? Brilliant. Now, that really is the most sort of very beginning of everything. Let's get a repository, let's make a change, commit a change, push it up, a little bit about credentials, a little bit about how we write a little bit of Markdown. There are more things to talk about. Next, we probably need to talk about branching and merging branches and cherry picking changes, branches, and resolving conflicts between changes, and diffing and patching, and then we may get on to some more advanced stuff. But let's leave that for the next session. Hope you enjoyed this. Please put any comments below and have fun. Okay.